Good morning, everyone. Thank you for joining us for this webinar, this OEM for Integrated Solutions for Advanced Applications. Very lucky that we are joined by different companies this morning. We've got Sonia from Crest Optics, got Aaron from Teledyne Photometrics, Simon from Prior, Matt, we've got Marina from CoolEd, and I'm Ben from CoolEd as well. Bit of admin just before we get going, just to let you all know this is being recorded, and we'll be sending out the recordings in a couple of days after this has happened. If any questions pop up while we're going to be playing these videos, please there's a Q&A tab at the bottom, so please type your questions in as and when they come into your head, and we'll have a Q&A session at the end. If you prefer to remain anonymous, you don't have to ask a question during this session. All the contact details will be sent out at the end as well, so you can ask relevant companies about whatever it is that's popped into your head. So the idea is I'm just going to play a video, a presentation from all four of our companies all in a row. It's roughly about 20 minutes, and then we'll reconvene at the end for our live Q&A where you can ask this wonderful panel of experts. So I will let me share the video with you all. And grab yourself a cup of tea. Relax. And we'll see you on the other side. We are CoolEd, an established UK-based designer and manufacturer of LED illumination systems. We supply OEM partners and researchers across the globe. For over 15 years, we've helped accelerate the move away from mercury and metal halide lamps. Our LED technology offers our partners the benefits of energy efficient, long lifetime illumination that's easy to control and simple to integrate. At the heart of our offering is our LED technology platform, engineered for precision, stability, and flexibility. Our designs allow for single or multi-channel systems covering wavelengths from UV to the near-infrared and into SWIR. We have fast TTL switching, USB control, stable output, which make our systems ideal for OEM integration. And unlike traditional mercury and metal halide lamps, LEDs consume far less energy and produce very little waste. And what makes CoolEd really stand out is how flexible we are when working with OEM partners. We don't just deliver a light source, we adapt to your system. That means you can focus on your core technology while we ensure your illumination is reliable, consistent, and future-proof. Our systems power a broad range of life science and industrial imaging applications, including things like fluorescence microscopy, confocal and spinning disk microscopy, optogenetics and neuroscience, high-throughput screening, metrology and defect inspection, or semiconductor wafer inspection. We focus on building a long-term collaboration that helps your system succeed over and over again. And we understand the importance of reliability, documentation, and lifecycle support, which makes integration smoother for engineers and product managers alike. Our dedicated OEM team works closely with partners from initial concept to the finished system.
Hi, my name is Marina, and I am the Global Business Development Manager for Life Sciences here at Kooled. So my role is that I work with you to understand your needs, your pain points, and your blue sky wish lists for your OEM product. Then I liaise with our technical teams, and together we devise a solution. We all work together to nail down a concept, to create a prototype for you to test. We then progress from there until you have your own custom light source, giving your product a cutting edge in an ever more competitive market.
Now, because our products are designed for seamless control and integration, they pair effortlessly with cameras, objectives, filter wheels and automation systems. And products from partners like Crest Optics, Teledyne and Prior Scientific, we can create a complete OEM imaging platform. We are so proud to be part of this network, and we'd love to talk to you about how we can bring your next system to light.
Hello everyone, and welcome to this webinar, OEM Network Integrated Solution for Advanced Application. My name is Sonia Montanari, and I'm a Trade Marketing Manager here at Crest Optics. This webinar will explore our unique business models, where we empower your brand with our cutting-edge technology. Crest Optics was founded in 2011. It's located in Rome, and it's a dynamic and innovative provider of microscopy solutions. We primarily serve research labs, pharmaceutical companies, and biotech firms through an indirect partnership model, leveraging three core approaches. ODM, supplying Crest Optics branded spinning disc confocal and super resolution system. OEM, providing custom design optical components for partner products. And hybrid solutions, seamlessly integrating our technologies with partner imaging platforms. Now let's look forward into the three fundamental approaches to industrial development at Crest Optics, outlining our strategic interconnecting pillars for innovation and how we ensure sustained growth and relevance. The first pillar is product evolution, incremental improvements. This represents our commitment to the continuous development of core and established technologies for short to mid-term objectives. It's about refining what we do best and making our existing highly successful spinning disc platforms even better. The second pillar is portfolio expansion, which focuses on breakthrough technologies and markets. This involves pursuing more disrupting advancement in technology development to support business sustainability in the long run. This is where we explore novel concepts and push the boundaries of microscopy. The third pillar is project for industrial partners and advanced integrators. This involves the development of custom solutions for clients with special needs and for specific applications. We focus on the adaptation of existing Crest Optics system to fit your needs. This allows for the seamless integration of our technology into your microscope and your software. We also offer flexible co-branding and white label solutions to meet your specific market and brand requirements. You can easily add confocal or super resolution capabilities to your product line without the need for extensive in-house development. Our approach leads to reduced investment and a faster time to market for new products. And you gain access to our proven reliable technology, which is optimized specifically for your platform. And the next 3 slides will give you some examples. I would like to begin with a key partnership with Tissue Gnostic and showcases their Tissue Fax Q family of confocal systems. These systems are designed for high-resolution tissue cytometry, which is essential for detailed analysis in many research labs. These systems are available in multi-configuration to fit a variety of lab setups and research needs. The second example is our hybrid partnership with TomoCube. Their HTX1 Plus holotomography system is an exceptional platform. Together, we have created a truly integrated, stable, and high-performance correlative solution. And to achieve this, Crest Optics optimized the design of the X-Lite V2 spinning disc confocal. That's a perfect example on how a hybrid partnership model works. We provide the core technology. Our partner delivers a groundbreaking, comprehensive solution to the market. Another powerful example is the partnership with MBF Bioscience to create the Vesalio system, which is built for fast confocal imaging. It's ideal for performing quantitative imaging analysis using the latest AI technology and integrating with software like Stereo Investigator and NeuroLucidity. While our advanced integrator model offers a fast and effective way to adapt our existing technology to your needs, some projects require a more fundamental foundation approach. For the visionary ideas, we have an OEM model that provides custom and complete customization for the ground up. Our OEM business is all about providing technology for third-party partners. We specialize in development of custom solutions for your clients with special needs and for specific application. The core of our business model is the promise of a complete customization in terms of specification, control, and design. And at the heart of this, what we call the power of a silent partner. We provide you the high-performance optical, mechanical, and electronic components that form the very much foundation of your product. To maintain full control of the final product, you will do the branding and the customer relationship, while our technology acts as the powerful, reliable engine within. So our final message is very clear. It's a call to action. Partner with us to advance your microscopy. We give you the tools to enhance your product line and bring your visionary ideas to life. Thank you all for joining us today. To stay informed about our ongoing innovation, please visit our website, subscribe to our newsletter, contact us directly, and don't forget to follow us on social media. We also invite you to explore the OEM network created by QualityD. It's your trusted directory for sourcing critical components in life science and more. They connect you with curated lists of top suppliers to simplify and accelerate your OEM search. Finally, I want to extend a sincere thank you to our partners in this webinar, QualityD, Prior, and Teledyne, and we appreciate your continuous collaboration in the extremely effective work we do together. Thank you so much for your attention, everyone, and we are now happy to take any questions you have in the Q&A session.
Hi everyone, I'm Simon Bush, the Product Manager for Microscopy Products and Projects at Prior Scientific. It's great to present on behalf of Prior at this webinar. Today I'm going to speak about how Prior has helped companies spin out their technology into unique instruments underpinned by our expertise in microscope automation. Prior has long been known for its high-precision microscope automation equipment, but our mission as of 2025 has evolved beyond this in order to provide more complete systems. Our aim with this can be summarized in 5 points. To help research-only and novel microscopy modalities to become mainstream, to make automation the standard for microscopy, to build a design-to-production partnership with our clients from prototype to final product, to use our expertise in production, logistics, compliance, and supply chain to fill gaps in our clients' knowledge, and to contribute to and share in the commercial success of our clients. The majority of our projects start with our OpenStand imaging system development platforms, of which there are 4 variants. The OpenStand U, a generalist system that offers the most imaging modalities, and has been used for both low-end automated microscopes as well as high-end confocal systems. The OpenStand M, a dedicated reflected light focused system in a compact format, ideal for system integrators. The OpenStand L, a large format system that not only caters for large and heavy samples, but also provides reach and clearance in complex setups. And finally, our most popular type that we've sold last year, an inverted system, the OpenStand V, that has been used for both life science and industrial applications. We used an OpenStand U as the basis for our project with Sparta Biodiscovery, a spin-out that have developed a unique laser trapping method. This case study highlights how Prior can help new companies to bring new technology to the market. So who are Sparta Biodiscovery? They aim to develop tools for nanoformulation analysis and quality control for next generation pharmaceuticals. They were a spin out from the Stevens Group at Imperial College London. The technology is underpinned by the research of Dr. Jelle Penders, who is now CEO of Sparta. And as a result of all this work commencing in 2020, they've now entered into a partnership with Sartorius. What is their instrument, the Aegis one? SPARTA stands for Single Particle Automated Raman Trapping Analysis, and it uses a 785 nanometer laser to trap individual nanoparticles in an automated fashion. It uses a customized detector assembly for its analysis, and it contains XYZ motorization from prior that has then been used with dedicated software developed by the SPARTA team. The system is used primarily in research as well as in drug discovery, and the system, importantly, is laser safety compliant in multiple markets, in part due to the prior designed interlock system that we put in when creating the system for them. SPARTA first contacted us, as I said, in 2020, and they're able to move quickly initially. Since their system required a high-class laser, the OpenSTAN was integrated directly into a box instrument from the first prototype, alongside the laser and the prior designed interlock electronics. This proof of concept system was essential, as SPARTA were wholly reliant on funding to continue the project at this stage. After this rapid start, SPARTA needed to develop their business and acquire additional funding. During the nearly 2 years required to move the business forward, the prototype played a big part in SPARTA getting funding to place an order for a number of beta units late in 2023. During that 2-year period, Prior provided as much support as needed to plan for the next steps, such as budgets, design revision ideas, and information on compliance testing requirements for the different markets they were targeting. Following successful completion of that compliance testing with the beta units, SPARTA ordered their first official production units in 2024. And wanting to expand into the US, they consulted Prior on compliance testing for this market. Prior ultimately facilitated this testing once again, and the last of this batch of units were delivered at the end of 2024. Now looking into this year, we've undergone a number of design changes, and we're very excited to hopefully receive the next order for the next generation of Aegis 1 very, very soon, towards the end of this year. If you'd like to know more, please check out our website, which places our design and productionization capabilities front and center, or contact us for more information. Thank you very much.
Hello everyone, I am Aaron Meta-Hill and I'm here today representing the Teledyne Scientific Camera Division. Thank you all for being here today and to learn more about our OEM offering. Now, before we get into that, I thought we'd take a moment to explain who we are. So on the screen right now, you can see the entire Teledyne Digital Imaging Group. And as you can see, it covers a lot of technologies. Our group enable a lot of different imaging applications, from looking at tiny cells through a microscope to entire star systems in deep space. Our group is on the right-hand side in the scientific division. Within this scientific division, we have several companies that you may have heard of, such as Photometrics. However, it's probably easier to break it down by technology. So if we start on the left, we have an entire company dedicated to single element and linear detectors for the IR range. These are the most basic level component we actually sell. And as you can imagine, it is solely focused on OEM integration. Then moving on, we have our scientific CMOS cameras. Some of these products are market-leading research products, but others are actually a huge part of our OEM business, which is almost half of all of our camera business, actually. Here, we really specialize in having the best image quality and the best reliability on the market. The reliability being a crucial part of our ability to be a premier OEM provider. Here, we mainly provide off-the-shelf cameras, as well as some custom products and some private label options too. Then we have our deep-cooled CCD cameras. We've been manufacturing CCD cameras for decades, and within Teledyne, we actually manufacture all of the CCD sensors that you're likely familiar with too. We specialize in low noise through our deep cooling, and also we offer lifetime vacuum seals on all of these products, which again is very attractive for an OEM component. And our CCD offering spans both imaging and spectroscopy. the latter being a big space for us and also rapidly growing with particular markets. Last and by no means least, we also manufacture scientific grade SWIR cameras using InGaAs sensors, which is another growing space for us. In particular, because we will soon be launching a scientific SWIR camera, which will use a unique sensor that we've manufactured ourselves. This is going to overcome a lot of issues associated with InGaAs that prevent its use in scientific applications, primarily related to the high levels of noise. These cameras are also both used for imaging and spectroscopy, and the use cases for these applications are seemingly growing every day. With this range within our group, we have the largest and most diverse imaging offering of any company, really, combining the different technologies as well as the market knowledge we've built up over the years. So, how does this relate to the other companies on this webinar? Well, in its simplest form, we have here a very basic diagram of a high-end confocal microscope. This one in particular is made up with accessories from our partners. You have the microscope, a confocal unit, light source, and then our cameras on the left-hand side. And this is typically how a lot of research microscopes are built up with third-party accessories. Not to oversimplify things, but when talking about instruments that we provide OEM components for, and in this case, I mean our cameras are likely hidden within a closed system, it is pretty much the same combination of components. When building a microscopy-based instrument, you still need those separate components that you saw in the previous system. But in this case, you'll still need an objective, a stage, light source, etc. And for us, most importantly, these systems often require a detector. So this example really highlights our message that when building a system like this, why wouldn't you look to the top companies in the research market to find high-quality OEM components? All of the companies on the OEM network fall into that same category of serving the scientific community, both direct to research and within instruments like this, where you may never know they're being used. Now, as much as I would like to share some information about customers that use our OEM products, that is all confidential. However, I can give you an insight into some of the use cases and applications where we have success. Now, for our SCMOS products, we specialize in high throughput systems, whether it be speed, large imaging areas, or both. And that is an area where we are the best option out there. We do all of this whilst avoiding any compromises on image quality too. Spatial omics and high content screening are two areas where our products fit really well because of the throughput. Also, applications that require large imaging areas as well as high speed, such as light sheet microscopy or voltage imaging, are other key applications for our OEM products. We also have some products that address wider imaging areas, such as live cell imaging, through more widely used optical systems where the large area might not be as accessible. And more recently, we've released some entry-level products aimed at lower cost systems. For our CCDs, that deep cooling I mentioned before is a necessity for certain instruments, such as in vivo imaging systems for small animals. We have some of the lowest noise cameras out there, which also helps drive completely other different areas, such as astronomy. A more relevant area for this is chemiluminescence-based systems, such as gel documentation or Western blot instruments, as well as other techniques that are used for immunoanalysis and toxicology. That's also something where we're able to address this with our CMOS cameras, as we've been able to get very, very low noise on our new CMOS products, which helps facilitate the end of life of certain Sony CCDs that are really popular in this space. And then finally, as I mentioned before, we have a lot of use cases within spectroscopy. Here we have another big advantage in that we also provide CCD coatings, which can provide better sensitivity in the near infrared, things like Raman spectroscopy, or in the complete opposite direction for the UV. Both the near infrared and the UV are really useful for material science applications within the semiconductor market, for example, which is also a growing area for us, both with spectroscopy and hyperspectral approaches. There's a lot of information to get through today in a very short amount of time. So of course, if there are any specific questions, you can get in touch with me directly or find out more on our website. A lot of our OEM capabilities are not explicitly mentioned on our website, which is why we always prefer some direct contact to truly discuss what we can offer. Thank you all for your time, and I hope to hear from some of you soon.
So I hope that was useful and gave you guys a good idea of the sorts of things that that we can do and these other companies can do. We've got a couple of questions still yet to answer. We've got one for Coolid. Which spectrum do your light sources cover? Do you cover the full spectrum? Marina, do you want to take that one?
So yeah, thanks a lot for the question. We did have a graph appear, but I know that was fleeting in the video. So we cover a range from the UV up to the IR and into the SWIR. Basically, if the LED exists, then we can probably get a hold of it and incorporate it. We have it where you can do single channel control, or if you wanted to have all LEDs on and have the more white light, that's also something that we can do. So I guess this is where we then get into that nitty-gritty conversation of what's your application, what wavelengths do you need, what fluorophores do you have, and we can make sure we tailor those LEDs to target that. But if you have any specific questions or want to get into that nitty-gritty, my email will be shared after this.
Thank you.
I can jump in on the question for Crest Optics that I said I would respond during the Q&A. So my question to Crest was, can you please list the most valuable applications you can tackle? So we are tackling quite a few, obviously application for any sorts of biomedical research, and the most common one, it's live imaging, high content screening, tissue imaging, and everything that is large field of view and fast and gentle on your samples. But also we can go pretty much in depth using different disk geometry. So we can also look at samples which are clear or not clear in depth within your tissue. And what is most valuable to mention, our systems work with both low magnification and high magnification lenses. So according to your application, you can pre-screen your tissue or your sample and do some eye content. But then if you want to go to higher magnification, higher resolution, obviously it's worth mentioning, we can also implement super resolution in our systems, therefore get much more details within your samples.
Thank you. So question, Aaron, do you want to go for your one?
Yep. Thank you for the question. So in terms of highest speed, there's really two ways of looking at it. So there is the speed at the full resolution. So when you have the full array in use, and we have cameras which can do kind of a standard 2K by 2K array at around 100 frames per second. And we have some that can go up to 500 frames per second at an even larger array, so about a 3K by 3K. But in terms of if you want to reach the highest speed as possible, so we have this for certain applications. So for imaging, things like voltage imaging, where you need a minimum 1000 frames per second to resolve like an action potential, or even things like more of a line scan approach, like hyperspectral imaging, then we can go up from thousands to tens of thousands just by reducing the field of view. One of the cameras where we do this really well on is our Kinetics. It uses PCI Express to handle that full frame rate. And when I say tens of thousands of frames per second, we have tested and validated that we can provide recommended PC builds. And we do have some people using these really high speed applications with that camera. Largest field of view for the sort of more life science orientated products, it is that Kinetics camera again, which is about 30 millimeters. But we do have some spectroscopy and even some astronomy cameras which go much larger than that. Some of them with sensors we actually design ourselves.
Thank you. I think might be all the live questions. Got one last chance to fire any live questions our way. But as I say, the recording of this will be available in the next couple of days. We'll email that out to everyone who's attended. And if anyone missed it as well, they'll be able to download and watch the webinar again. That will also include the contact details of all of our companies. So if you've got a specific question that you haven't thought of, or a more in-depth question you want to fire out, then you'll be able to get in touch with all of these great companies all at the same time. One more. Smallest device you can design for. Which company is that for? That might be one we have to come back to, or if you can elaborate on that question, Murdine.
In the meantime, Simon, do you want to also discuss the question you received?
Thank you, Sonia. I think my answer was pretty clear, but yeah, just to reiterate for the benefit of the audience, Pri is integrated with, I guess, various players in the microscopy space. You've got the more open microscopy softwares like VisiView and Inscopur, who have integrated a wide array of third-party devices, including those from all of the participants here. We've got a high level of integration with both of those. The majority of our components are in there. And then Pri is also integrated with other major players who've got kind of tighter control over what hardware they offer with their systems as well. That being said, from an OEM perspective, we also offer an open access SDK and DLL. And that's the way that most of that clientele interface with our hardware. You know, they're trying to build a custom workflow and a unique user experience, and the fact we've got that open development kit helps them with that.
Fantastic, thanks, Simon. If there's no more live questions coming in, we can probably end it there. But I just want to say thank you so much to all of you guys for joining us, and obviously the companies, and Sonia, Aaron, Matt, Simon, Rachel, Marina. And from myself, Ben, thank you ever so much for joining us. Oh, we've got one more. Oh, how can I get details of product and price? Again, that might be better directed if when we send out the follow-up email at the end, it'll have the contact details of all of our companies in it. So please do ask as many questions as you want. But for now, thank you ever so much, everyone, for joining us. And I hope it's been useful.
Thank you, everyone.
Thank you, guys.
Thanks, everyone.
Thank you.
Bye-bye.